Welcome to another devlog on Smalltown Architect, a cozy city builder which lets you create beautiful European-style old towns. In my last video I went through the beginnings of my project and showed some of the core systems of the game, including procedural houses, the paving system, and the pedestrian simulation. Well, there has been quite some progress over the last month or two, so let's jump right into it. Before we get into the technical stuff, let's talk about market research. I know, not super exciting, but stay with me. So last time I showed you a little Reddit post I made of an early video of my game to get a sense of whether people like the general direction or not. And I mentioned that I've been pretty pleased with the results and responses. Well, since then I continued this practice a few more times. I selected a few subreddits focused on urbanism, which I think is one part of my target audience. I then created these videos where you demolish bad infrastructure and replace it with cute little walkable towns. And wow, people really liked those. I did not expect such positive responses, but of course I was super happy and now confident that this is actually something people want. This kind of market research, if you can call it that, was super helpful and something I completely neglected with my previous game. I can also recommend doing this as early as possible, because at least for me it gets infinitely harder the more attached you get to your idea and the more time you're already invested in making it. Knowing people actually care about this game definitely gave me a huge boost in motivation, so let's see how I used it. But before that, it would mean the world if you'd take just a moment to wishlist Smalltown Architect on Steam. Thanks! So one thing I wanted to do for a long time was to do a little visual overhaul. I like the visual style the game is taking on, but there really were some elements that bothered me and some of the friends I showed the game to so far. One such thing was the paving, which appeared quite blurry and low res, especially on the edges where these clear cuts didn't really work out. So I took on the challenge to fix that. The first and most obvious step was to increase the resolution of the terrain's alpha maps, also known as splat maps, which are basically the textures that contain the data on where on the terrain which texture is painted on. The default here was 512 by 512 pixels, which for the size of my terrain wasn't nearly enough to get sharp edges. So I changed it to 2048, essentially quadrupling my original size, which completely tanked the game's performance while using the paving tool. Turns out my solution wasn't really scalable since it ran on the CPU. After doing a bit of research on potential better solutions, I learned that A, this doesn't seem to be a very frequently discussed problem, and B, there is an experimental Unity API for GPU-based terrain manipulation, which was casually mentioned one single time by this Unity staff member, alongside a decent code sample on how to use it. So very cautiously optimistic, I decided to give it a shot, and lo and behold, after a few tweaks it actually did something. And most importantly, it did it really fast. So what the hell, Unity, for burying this API so deeply, but still, thanks I guess. To improve the visuals a little more, I also found this little outlines option in Microsplat, which makes the edges and transitions of the paving look a lot nicer in my opinion. Finally, I added grass, which I avoided for quite some time, but actually it turned out to be relatively simple, at least compared to what I had to deal with before, and it definitely added a lot. I'm using the regular details system of Unity's terrain, which I think was broken for quite some time in earlier Unity versions, but now it seems to work fine again. Grass obviously adds a lot of geometry to the scene, so you have to be careful to use rather simple meshes. The main challenge here was cutting the grass whenever the player paves over it. Since there is no method for editing the details on the GPU, I had to go back and use some of the code from my old approach, but in that case it was completely fine performance-wise. The result definitely feels a lot more satisfying with the grass. I want players to be able to fully modify the terrain to build their towns on hills, mountains, or into valleys. I quickly showed my simple terraforming tool last time, but this was also running on the CPU and suffered from the same problems as the paving. Luckily, in my beloved experimental API, there is also a method for editing the height map, which is exactly what we need. Now, terraforming also feels a lot smoother. By holding Control, you can set the terrain at a specific height, and by holding Shift you can lower the terrain, but by a level which eventually turns into a body of water. I'm even changing the sound effect to reflect this. One thing worth mentioning is that I'm using the procedural texturing feature of Microspread, which automatically assigns this cliff texture to steep slopes. This introduces a few new problems though. The procedural texturing system takes full control of painting the terrain based on certain rules. Luckily, there is an option to combine this with custom splat map data, for instance our paving. However, enabling this allows me to paint over everything, including the cliffs, which is definitely not what we want. Apparently the best solution here is to just skip drawing on cliff areas in the first place, which turned out to be a lot more complicated than it sounds because we are drawing on the GPU. Without boring you with the details, I managed to find a solution which involves compiling a texture with the cliff information at each point of the brush and sending it to the GPU each frame we are drawing. Whew, let's talk about something more relaxing again. Procedural tree generation isn't exactly a new science, and tools like SpeedTree have been around for a pretty long time. So why didn't I just buy one from the asset store and call it a day? Well, first, where's the fun in that? And second, these tools are often bulky and come with quite a bit of overhead. You often have to spend quite some time learning these tools, figuring out how to achieve what you intended, and if you run into any problems or limitations, you really have to dig deep in order to understand how the tool actually works from the inside. Considering all of this, I definitely had cases where it would have been faster to implement the solution myself, with the added benefit of completely understanding the system and making it very easy to extend it. So from my experience, it's not always 100% clear if it's worth to implement my own solution. But in the case of the tree generator, I'm glad I did, because A, it was an interesting problem to solve, and B, I now have a pretty decent system that's well integrated into my game. So how do you start generating a tree? Well, ideally you would probably look up some paper on tree generation, but my goal wasn't to create a state-of-the-art realistic tree generator, but rather a simple way of creating somewhat believable trees that fit my art style. So I tried to observe some trees and come up with my own algorithm. As many things in nature, trees are kind of a fractal, meaning they have a certain pattern that is repeated recursively, getting smaller and smaller each time. So in theory, it should be enough to define how a single branch behaves and then execute that behavior recursively a number of times, depending on how large and dense our tree should be. We can also use Unity's object hierarchy, which is a tree data structure, so it's of course perfect for representing our tree. So my first approach looked like this, which looks more like a weird crystal structure than a tree. After tweaking some of the values, this was the result, which is something but still nowhere near an organic looking tree. I added some leaves at the end of each branch and the result looked slightly better but still not great. I continued to rewrite a good chunk of my code because I realized I was missing a few important elements. Most importantly, that a single branch contains multiple segments which kind of propagate into one direction. Only occasionally do we branch off in an entirely different direction. This change had a really big impact and my trees started to look like actual trees. Another important detail is that trees grow towards the sun, so I added a parameter that defines the uprightness, if that's a word, of the branches, which I then lerp towards vector3.up, which seems to do the job. Finally, for the leaves, I replaced these low poly meshes with a set of randomly rotated textured quads, which I think also looks a lot better and still fits my art style. Adding some pop animation and sound effect, and we now have a fully customizable procedural tree generator, which by changing a few properties can produce a variety of different tree types. In the end, definitely time well spent for a pretty reusable asset, I would say. There'd be plenty more to talk about, but to wrap up this devlog, let's check out one more little feature I added, which is the third-person observer mode. Kind of like in Google Street View, you can place your observer anywhere on the map and your camera will zoom in and let you experience your town from the perspective of a pedestrian. You can freely walk or run and look around with your camera. You can't really interact with anything or anyone at the moment, but I think this could be a funny addition for the future. This feature got pretty good reactions when I showed it in videos. Apparently it's not a very common feature for city builders, despite its simplicity, so I'm glad I added it early on. It's also great for recording footage from a different perspective than the regular top-down one. Alright, I think the game is starting to take shape and I'm pretty happy with my current pacing. Behind the scenes, I've been experimenting with different gameplay scenarios. It's still not quite clear how it will look like in the end, but it's definitely something I'm actively working on. I'm also already thinking about a public demo launch, but I want to do a good amount of private playtesting first. Definitely a lot to look forward to, so if you want to support the game, feel free to wishlist on Steam. See you next time, thanks for watching.